All right. So Sam, you said WebWork 1, problem 9?
Yeah, the last one.
All right, let me bring that up.
Wasn't sure how to set that one up.
Okay, so this is the 25 heat lamps are connected in a greenhouse so that when one lamp fails, another takes over immediately. Only one lamp is turned on at any time. We want the probability that a lamp will be burning at the end of the 1300-hour period. All right, so what have you tried for this one?
So, well, I was writing down all the numbers, and I have like the probability of big Y is like greater than 1300, or 1 minus probability of Y being less than or equal to 1300. But then I wasn't sure what to plug in because we have the number 1300 hours, but then N is 25. So it's just getting mixed up with the amount of numbers I see in the problem, I guess.
Yeah, so what does Y represent?
That would be like how many like hours I think that they're burning, or is that individual?
How many hours that what is burning?
Just any of the lamps?
Yeah. So Y, if we let Y be the total length of time that any lamps are burning, you're finding the probability that Y is greater than 1300.
Yeah.
So how does that Y relate to, sorry, there's some background noise.
Yeah, I don't know.
Okay. So how does that Y relate to the individual heat lamps?
Well, so there's 25 of them are all independent. So, I'm not sure.
And when does one get turned on?
So they're one after the other, so they're consecutive. That might be the part that's tripping me out because they're not all on at the same time. We have to wait for one to die first.
Right. So let's say if we simplify this a little bit, if there are only 2 lamps and the first one burns out after 3 hours and then the second one turns on and stays on for 4 hours, what would Y be, the total length of time?
Wait, sorry, what was that? What was the question you asked?
So let's say the first lamp is on for 3 hours and then burns out, and then the second one is on for 4 hours. What is Y, the total length of time that the lights are on?
7.
7. How do you know that?
Just add them all together. Oh, it's a summation, isn't it?
Right.
Okay. So are we summing just from 1 to 1300 of?
So no,
I don't. Yeah.
So you can think about there being sort of 2 different sets of random variables. There's Y. I'll do this in the chat so we can let Y be the total length all lights are on. And we can let like X sub 1 be the length of the first light.
Okay.
And X sub 2 be the length of the second light, and so on.
Right.
So then Y is the sum of the X sub i's as I goes from 1 to 25.
Right.
And instead of working with the sum, what might be easier to let us use the central limit theorem?
I know we've done this before, haven't we? I'm forgetting. Let's see. What are we doing?
So we did a problem like this in class where it was the total service time
Yeah.
for 60 different customers. What did we do for that problem?
Don't remember. Trying to find it. Which one was that though?
So it was on the central limit theorem activity. It might have been problem 5.
Oh yeah. So then I don't know. Okay, I don't know. I don't have any summations like written down for that problem, so I don't know how to switch it over. So we're trying to find that the probability of the total time is greater than 1300, which means that yeah, I'm not sure.
So what did we do in that problem?
We used a normal CDF because we changed the probability from y sub 60 is less than 1 minute. So is that kind of what we're doing again?
How did we get that? Why was that? Why did that work?
Oh, I love this.
I don't know how to translate this problem to that problem.
So both of these problems are dealing with a total of something, a sum of something.
Yeah.
And the way we solved the one in class was by saying, instead of finding the probability that the sum of the service time for 60 customers is less than an hour, let's instead find the probability that the average service time per customer is less than 1 minute.
Yeah.
So do that here. Instead of finding the probability that the total time that the lights are on is more than 1300, find the probability that the average time that the lights are on is per light is more than 1300 divided by 25.
Oh, okay. Okay. So then we would do like the normal distribution, but with yeah. Okay. That kind of makes sense. Because then we're going from 0 to 1300 over 25. For like the like what we're plugging into the normal CDF.
Yes.
Okay.
I would actually do it from negative infinity to 1300 over 25. The mean is far enough from 0 that it's not going to make much of a difference. But
Okay.
when you're using the normal approximation, you don't want to cut off and get rid of the probability of something being less than 0, because then your total area under the normal density curve isn't 1 anymore.
Okay. Okay. That kind of makes sense. Okay. Cool. I think I can go from there. If I just, yeah, I'll just look at that problem.
Sounds good. Any other Math 347 questions while we're here?
I had just a quick question. Not full on question like that, but
Sure.
On problem 7, it's just the yes or no questions.
Uh-huh.
Because when I like did the equation for that, all of the n's were greater than 9 times max over min. So like for B there, when I did 0.95 over 0.05 times 9, I think I got like something 171. So wouldn't it work there as well?
For B?
For B, oh wait, they're you have different numbers, I guess.
So what were your numbers there?
My numbers were n equals 190 and p equals 0.05.
Okay.
And 0.95 over 0.05 times 9 is 171. And
Yep.
190 is greater than 171, but the answer that they have is no, it doesn't work.
Let me stop
And that
sharing
was,
and let me go into the
yeah,
code of this problem.
I just want to make sure I'm not missing something because it seemed wrong to me.
Okay. My apologies. It looks like I might need to edit the code of this problem some to make sure that all of the numbers work out correctly.
Okay,
so I will work
cool.
on that this afternoon. Sorry about
Cool.
that.
Yeah, it's fine. I mean, yeah, I still like got 100%. I just was wondering if it was wrong or if I was crazy or something, but sounds good. Other than that, that's all the questions I had.
All right, sounds good.
Thank you.
You're welcome. I will switch the recording back so we can talk more about 740.